I cannot, it's the acceleration that allows me to detect the fragility, the acceleration of harm. If I have a bad ruler, I can't measure a child, the height of a child. You agree? It's very hard. But I can tell how fast he's growing in percentage. You agree? So I don't have to have a great measuring tool for fragility. All I need is to detect the second order derivative, the acceleration, because fragility is in acceleration. Now that I gave you the difficult stuff, let me talk about my book. Everything reposes on this idea that fragility is in a concave. And if I learn how to work this, hold on, this is a concave. The concave is fragile, and you can see the benefits, all right? And the concave is anti-fragile. To give you an idea why the concave is fragile, your grandmother, if you have a piece of information that your grandmother spent 2 days at 70 degrees Fahrenheit, you know, as sole information, you would assume that your grandmother is very happy, no? That's the perfect temperature for grandmothers. But if then the second order, your grandmother spent the first day at 0 degrees and the second one at 140 degrees for an average of 70 degrees. I think you would be thinking about the inheritance and all the things that come with funeral, no? Okay. So is fragile what does not like a negative second order effect, and is therefore anti-fragile what likes variation and likes these second order effects. Let me try to work this because I'm a little confused about this. How to work the computer, okay. Figured out how to work it. So let's stop with the graphs and let me talk about the book. Now you're confused enough, but intrigued. So let me talk about my book after I showed you these technical definitions. Well, this book, I realized that this property of anti-fragility, once you had definition of fragility, then you have its opposite, was misunderstood in the discourse. Like when governments want stability, they shoot for perfect stability, but something that is organic requires some amount of volatility. It's the exact opposite of the grandmother. There's a mathematical property called Jensen's inequality that tells you that often things gain under variability. There are a huge amount of phenomena like that. In other words, you do a lot better yourself if you spend an hour at 50 degrees and an hour at 80 degrees than if you spend 2 hours at 65 degrees, for example. That Jensen's inequality. Anything convex, actually, this is a graph of Jensen's inequality. Okay, here it is. Okay, it's complicated, I told you, all right? So let me remove it very quickly. So there are things that like variation. So you can classify things in 3 categories. The fragile is what does not like volatility, randomness, variability, uncertainty, stressors. The robust doesn't really care, like the book and bridge. And the anti-fragile requires some amount of variability in all of these. The discourse missed completely the notion of anti-fragile. So we try to get stability with government, for example. They want to have no fluctuation, and you saw what Greenspan did. If you gave him the seasons, he would have had the seasons at 67.8 degrees, the temperature year-round, like inside this office. That's what you maintain, I think. All right, inside the office, and of course, you know, we've blown up the planet. I'm glad we only gave him the economy. He only blew that up, okay? But we do a lot of harm by depriving something organic of a certain amount of variability. Anything organic communicates